Have you ever wondered, what if everything we see, the stars, the galaxies, the vast clusters of light, wasn't the whole story? What if, well, we're actually living inside a cosmic void, a vast, almost unimaginable emptiness stretching for billions of light years in every direction? You see, for centuries we thought the universe was evenly filled with matter. Stars scattered more or less everywhere, galaxies bound together by gravity in an endless cosmic web. But in 2013, three astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, discovered something that quietly shook that belief. They found that our home, the Milky Way, and everything around it, sits inside a giant cosmic bubble, a place where matter is strangely scarce, about 20% less than the average density of the universe. They called it the KBC void. And, it's not just an empty space. It's a whole 2 billion light-years wide. That's so large, so hollow, that by all accounts, it shouldn't exist. And yet, here we are, living right in the middle of it, floating, unknowingly, in a vast nothingness. So, if that's true, what does it mean? Are we in a special place? Are we misreading the universe because of where we are? Could this explain why our measurements of cosmic expansion seem off somehow? You see, this isn't just an astronomical curiosity. It's a challenge to the very foundations of cosmology. Because if the universe isn't as uniform as we thought, then perhaps the laws that describe it might not be either. And perhaps, well, that emptiness around us is not a flaw, but the very shape of creation itself, a reminder that even in the void, there is structure, rhythm, and meaning. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. And, I'd love to hear from you. Where are you listening from tonight? It's always fascinating to see who's joining us from all around the world. So let's continue. It began, not with a telescope pointed at a single star, but with a question. A question so simple that, well, it almost felt naive. What if the universe isn't as even as we think? That question lingered in the minds of three astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, long before 2013, when they would, unknowingly redraw the map of everything we thought we knew. For decades, the grand assumption had been clear. The universe, at large enough scales, is smooth, homogeneous, isotropic, the same in every direction. We built our equations on that faith. Every cosmic survey, every model of dark matter and energy rested on that quiet, unspoken belief that there's no special place, no cosmic exception. But then, well, data began to whisper otherwise. Keenan and his team were not searching for anomalies. They were building a map, a census of more than 35,000 galaxies across the local universe. A map meant to confirm the obvious, that galaxies are sprinkled evenly, like grains of sand scattered by gravity's patient hand. Yet as they looked deeper, counted longer, calibrated and recalibrated their instruments, a subtle pattern began to emerge. And, it was unsettling. The galaxies, it turned out, were missing. Not gone exactly, but scarcer. About 20% fewer than expected in every direction. Imagine looking out into space and realizing that no matter where you turn, the sky itself is thinner than it should be. That's what they found. A hollowness. A quiet undercurrent of absence woven into the cosmic fabric. At first, they doubted themselves. The universe couldn't simply skip 20% of its galaxies around us. Maybe the data was biased. Maybe dust, calibration errors, or cosmic variance. But as the months passed, the evidence grew heavier, steadier, undeniable. The void was real. And, well, it wasn't just a void in the ordinary sense, not some empty patch between clusters. It was vast, unthinkably vast, a sphere extending almost 1 billion light-years in every direction from where we stand, swallowing the Milky Way, Andromeda, and thousands of other galaxies inside its near-silent reach. They named it the KBC Void, after their initials, a reluctant honor, perhaps, because who really wants to be remembered as the discoverer of emptiness? Still, it was a discovery that shook the cosmic order. The largest underdensity ever measured. A hole in the universe so immense that even simulations, those digital universes birthed from mathematics, struggled to recreate it. Out of thousands of models, none produced something quite like it by chance. That meant either the universe was far stranger than we thought, or that our models, elegant as they are, were missing a crucial truth. The announcement, when it came, rippled quietly through the scientific community. Some dismissed it. Too big, too rare, too anthropic. Others leaned closer, intrigued. Could it be that we, of all places, live inside one of the emptiest regions of the cosmos? The odds seemed absurd, smaller than 1 in 1,000. But then again, the cosmos doesn't deal in comfort. It deals in reality. The discovery reframed everything. Our measurements of cosmic expansion, our understanding of dark energy, even the way light travels across space, all suddenly had to pass through this lens of emptiness. Because, well, if you live inside a bubble, everything you see outside looks distorted. Galaxies appear to recede faster, distances seem stretched, and time itself, in its subtle way, runs differently. And that realization carried a strange poetry. We measure the universe not from nowhere, but from within a hollow that might be shaping every conclusion we draw. It's not just a scientific footnote, it's a philosophical tremor. How much of what we call truth depends on where we stand? Still, the data kept insisting. This was no illusion. Each survey confirmed the same trend. Even the cosmic microwave background, the faint afterglow of the Big Bang, hinted at slight asymmetries, small ripples that aligned eerily with the geometry of our local underdensity. The KBC void wasn't just there, it was influencing the cosmos we thought we understood. Imagine, for a moment, what that means. 1 billion light-years of near-nothing. If you traveled at the speed of light from one edge of this region to the other, it would take longer than life on Earth has existed. And yet, compared to the full span of the observable universe, 93 billion light-years across, our void is a small depression, a gentle dent in the grand structure. Small, and yet profoundly ours. We live in the silence between walls. Outside our cosmic bubble, the universe is richer, denser, brighter. Superclusters thread together into filaments of unimaginable scale, glowing like cosmic arteries. But inside, the light thins, the galaxies fade. We are, in a very real sense, children of emptiness, born in the rare gap between the great filaments of creation. Well, maybe that's why the discovery feels so intimate, almost personal. It tells us not just where we are, but what we are. For centuries, we've wrestled with the idea of centrality. First, Earth was the center of everything. Then the sun. Then the galaxy. Then nothing at all. We were ordinary, lost in a sea of sameness. But now, we find ourselves somewhere unique again. Not at the center of power, but at the center of absence. That irony humbles and unsettles in equal measure. To be surrounded by emptiness on such a colossal scale, It forces a kind of existential quiet. The human instinct is to fill voids with light, with meaning, with noise. But the universe seems content to leave most of itself untouched. As Keenan once noted in a lecture, the hardest part wasn't the math, it was the acceptance. Because, once you accept that we are floating in a vast underdensity, you have to reconsider everything else. The expansion rate of the universe, the nature of dark energy, even the timeline of cosmic history. It's not that our equations are wrong. It's that they were written from inside a bubble, pretending it wasn't there. So, well, what do we do with this knowledge? How do we reconcile the measurable, physical truth of the KBC void with the emotional weight of what it implies? Because it's not just science, it's story. It's the story of how we realized, once again, that the universe doesn't revolve around us, and yet, somehow, still includes us in its strange design. The void isn't a mistake, it's structure. Modern cosmology now sees the universe not as a smooth soup of galaxies, but as a cosmic web, a three-dimensional lattice of filaments and voids. And here, in our corner, we are resting in one of the largest bubbles ever formed. That, might sound lonely, but it's also beautiful. Because without these empty spaces, the filaments could never form. The universe breathes through contrast. The KBC void became more than a finding. It became a question folded into every observation that followed. How do you measure reality when you are surrounded by distortion? How do you know the universe's speed, its age, its future? If your own neighborhood is bending the rules just enough to confuse the instruments? And so, as more data arrived, the picture deepened. Surveys of distant quasars, infrared maps, gravitational lensing, all confirmed that our cosmic bubble wasn't illusion. The density contrast, the gravitational gradients, the faint statistical fingerprints, all pointed to one truth. We are living inside an immense cavity, a hollowed-out sphere in the cosmic foam. That realization changes the tone of everything. Suddenly, the night sky doesn't just feel infinite, it feels fragile. Every star we see, every galaxy glimmering at the edge of perception, is part of a delicate balance between fullness and emptiness. The universe, it seems, was never meant to be uniform. It thrives on asymmetry, on difference, on the quiet dance between being and nothingness. And perhaps, well, that's the lesson hidden in the data, the one Keenan, Barger, and Cowie didn't intend but couldn't avoid. That emptiness isn't the absence of meaning, but the space that allows meaning to exist. Without the void, there would be no contrast, no perspective, no light. The KBC void, then, isn't just a discovery. It's an invitation to rethink not only the structure of the cosmos, but our relationship to it. Because when we look into the depths of that near-nothingness, what we really see is the fragility of perception itself. The realization that everything we know, every law, every measurement, is filtered through the quiet distortion of the place we call home. And, as we move forward, deeper into the next layer of understanding, one question remains. If our own region of the universe can be so profoundly hollow, what does that say about the universe as a whole? Is it truly uniform? Or is the cosmos, like us, filled with hidden irregularities, pockets of silence within the grand symphony of creation? Well, maybe that's where the next chapter begins. It's strange, how something that feels so vast can make everything else feel so small. After the discovery of the KBC void, the question that rose from the silence was not how big is it, but how wrong have we been? Because Well, the moment you realize you're living inside a billion light-year bubble of near-nothingness, the old maps stop making sense. The universe, the one we thought was smooth, symmetrical, obedient to its own equations, begins to look uneven, almost alive in its asymmetry. For decades, the standard model of cosmology, the so-called lambda cold dark matter framework, has told us that, at large enough scales, the universe must be homogeneous. It must, even out. No special spots, no preferred directions, no regions of exception. That principle was comforting. It made the cosmos democratic, impartial. But the KBC void, with its quiet defiance, suggests otherwise. It says, maybe the universe doesn't play fair. Maybe, and, this is the hardest part. Maybe we are living in one of the rarest neighborhoods of all. The numbers themselves whisper rebellion. Simulations of structure formation, those vast digital universes that scientists grow inside computers, struggle to create a void like ours. The probability, when you run the math, is less than 1 in 1,000. 1 in 1,000 universes might randomly produce a cavity as deep and wide as the one we inhabit. That's not just rare, it's almost poetic. It's as if the cosmos carved this hollowness for us to notice, to question, to doubt the idea of sameness itself. And yet, scientists don't like poetry in their equations, so they look for explanations, for symmetry lost somewhere in the data. Could it be a statistical fluke? A misreading of redshifts? Or, well, could it be something deeper? Something that cracks the foundations of what we think we know about space itself? When the Standard Model was born, it came with a promise that from chaos, order emerges, and from order, predictability. The early universe was dense, hot, and uniform to 1 part in 100,000. Gravity, patient and unrelenting, pulled matter into filaments, clusters, galaxies. But gravity, too, has limits. It can't make a hole this large without violating its own rules. So the KBC void stands as a quiet contradiction, a cosmic bruise that refuses to heal. The most unsettling part is not the void's size, but its meaning. Because if the universe is not truly homogeneous, then the cosmological principle, one of the most sacred assumptions in physics, begins to tremble. The principle says there is no special place, no cosmic center. But what if there is? What if it's not the center of everything, but the center of emptiness? What if, by pure accident, or some deeper pattern, we've found ourselves in the middle of a region where matter simply never gathered? And that, well, changes everything. If we are inside a vast underdensity, then every measurement we make, from the brightness of supernovae to the rate at which galaxies drift apart, is tinted by that emptiness. We think we're observing the universe, but we're really observing from within a cosmic distortion. It's like trying to measure the sea while standing inside a bubble underwater. Everything you see bends differently, and every sound arrives a little late. Still, there's resistance. Science, after all, thrives on stability. To question the cosmological principle is to shake the very scaffolding of modern physics. But the data keep pressing, insistent, soft as a whisper, but sharp as truth. Galaxy counts, peculiar velocities, luminosity distances, all converge toward the same quiet conclusion. The void is real, and it is ours. We've spent centuries moving away from the idea that we are special. First Copernicus, then Galileo, then Hubble, all erasing us from the center of creation. But the KBC void, brings back a strange kind of centrality. Not the centrality of pride, but of paradox. We are not in the middle of the universe, but we are, perhaps, in the middle of one of its great absences. And, that absence matters. Because if the cosmos is uneven, then its expansion might not be the same everywhere. Regions filled with matter tug against expansion, their gravity slowing time and stretching space differently. But inside a void, where gravity is weak, expansion wins. Space itself grows faster. That could explain why local measurements of the Hubble constant differ from the global ones. We are not measuring a universal truth. We are measuring a local illusion. Well, that's the haunting beauty of it. What we call the crisis in cosmology, the tension between different measurements of how fast the universe expands, might not be a crisis at all. It might be perspective. The universe is not broken. We are just, sitting in the wrong seat to see it clearly. And yet, so much depends on that clarity. Because if the standard model cannot explain our position, then it cannot fully explain the universe. The equations of general relativity assume smoothness on cosmic scales, but smoothness is an illusion carved by distance. Look closely enough, really closely, and the universe looks like lace. Filaments of galaxies twisted around cavities of silence, a three-dimensional web where voids dominate volume, while matter clings to edges like dew on a spider's thread. The KBC void, then, isn't an anomaly. It's a revelation. It tells us that most of the universe is nothing, and that this nothingness is not empty, but dynamic. It breathes. It expands faster than the regions around it. It sculpts the flow of galaxies like wind over dunes. It even bends light, subtly but measurably, stretching the path of photons as they cross its gentle gradient. There's something humbling about that. To think that emptiness can shape light, can sculpt time, can deceive even our instruments. It's a reminder that the universe's silence is not absence, but presence. That's what the KBC void forces us to see, that the quietest regions of space may hold the loudest truths. And when you listen closely, you realize that this isn't the first time the universe has whispered contradiction. From the cosmic microwave background to the distribution of quasars, there have always been hints of imperfection, tiny asymmetries brushed into the cosmic fabric like fingerprints. Maybe, the universe was never meant to be perfectly even. Maybe that's its secret rhythm. Order built from imbalance. Harmony drawn from dissonance. The more scientists simulate, the more this pattern emerges. Voids are not exceptions. They are structure. They make up more than 90% of the universe's volume. Matter, the bright stuff, is just the foam around the bubbles. The voids are the spaces in between, the negative space that gives the cosmos its shape. And, well, that's where the standard model begins to falter. Not because it's wrong, but because it's incomplete. It describes the universe as a whole, but it forgets to describe the hollowness within it. It assumes uniformity, but the universe prefers texture. That realization changes the way we think about everything, from dark energy to time itself. Because if the expansion rate depends on where you are, then so does your perception of age, distance, and destiny. Time inside a void flows differently, faster, cleaner, less burdened by gravity. It's as if, the universe itself breathes lighter here. And maybe, well, that's why we're able to ask these questions at all. Maybe intelligence arises not in the densest regions, but in the quiet in-betweens, where space has room to think, where light has time to travel unhurried. We grow older, clocks tick, galaxies drift, and somewhere in the silence, awareness begins. So perhaps the KBC void isn't an error in measurement. It's the condition of our existence. We see the universe as uneven because we are born inside its unevenness. It's not bias, it's perspective. It's not deception, it's location. And that, leads to a deeper, more unsettling thought. If our own patch of the universe is so rare, so improbable, what does that say about us? Are we, too, the product of cosmic chance, a ripple of life born in the calm of a void? Or are voids themselves necessary for consciousness to arise, a kind of cradle where silence gives rise to thought? We don't know yet. But what we do know is that the KBC void challenges not just the equations, but the assumptions behind them. It says the universe is not a perfect machine. It's a living landscape, scarred, stretched, breathing. And if we want to understand it, we must learn to listen to its asymmetries. Because in those asymmetries lies the next frontier, the place where the neat lines of theory begin to fray, and new physics, quietly waits to be found. The KBC void may be the first hint that our grand model, the one that ruled cosmology for decades, is ready to evolve. And, maybe that's where we go next. Not deeper into the void itself, but into the structure surrounding it, the filaments, the cosmic walls, the patterns that frame the emptiness and give it meaning. Because the universe, as we'll soon see, is not a soup of galaxies, it's a web of light and darkness, of density and silence, and it's within that web that the true story of existence unfolds. When you look far enough, when you really look, you start to realize that the universe isn't a smooth ocean at all. It's not, the quiet and endless field of stars that we once imagined it to be. It's rough, it's clumped, it's alive with pattern. And the more you look, the more that pattern reveals itself, not as chaos, but as a kind of cosmic architecture, an intricate web made of both presence and absence. That's the strange part, isn't it? The universe is built not just from what is there, but from what isn't. Matter and emptiness, dancing together, sculpting each other's boundaries. The galaxies form the filaments, long and thin like veins of light stretched across unimaginable distances. Between them, lie the voids, the great hollows, the vast silent spaces where almost nothing resides, and the balance between them is everything. Those filaments contain the galaxies. Yes, the stars, the clusters, the places where gravity has gathered matter like dust in corners. But it's the voids, the spaces between, that dominate the shape of the universe. More than 90% of all cosmic volume is empty, and yet it's this emptiness that defines the structure. Well, maybe empty isn't even the right word, because that nothingness isn't nothing. It's a kind of soft curvature in the cosmic fabric, a gentle slope where the density falls away, where the pull of gravity weakens and the expansion of space takes over. The voids are not holes, they're, lungs. The universe breathes through them. When cosmologists map the distribution of galaxies, they see not a random scatter, but a network, a lattice that stretches in every direction. From a distance, it looks eerily biological, like neurons glowing in a vast brain. The filaments connect, the clusters pulse at the intersections, and the voids open up between them like the dark gaps between thoughts. It's a web of everything and of nothing. So the KBC void, that enormous hollow in which we find ourselves, isn't an exception. It's part of that grand structure, one of the bubbles in the cosmic foam. It's just bigger than most, So big, in fact, that it sits near the upper limit of what our models say is even possible. But it's still part of that pattern, a cell in a universal tissue that extends far beyond what we can see. And that realization changes the question. The question is no longer, why does this void exist? But why does the universe build itself this way at all? Why a web? Why not uniformity? Why not randomness? Why this elegant, fragile balance of filaments and hollows? The answer, well, it lies in the way the universe was born. After the Big Bang, everything was almost uniform. Almost. There were tiny differences, tiny ripples in density, smaller than 1 part in 100,000. Those ripples, caused by quantum fluctuations in the first fractions of a second, were amplified by gravity over billions of years. The dense regions grew denser, the sparse regions became emptier, and, well, what emerged was structure. Galaxies formed in the dense nodes, filaments stretched between them like threads under tension, and the spaces between, the voids, grew larger and larger as matter flowed away from them. It's not chaos, it's evolution. The cosmic web is what happens when gravity sculpts time itself. We often imagine the voids as dead zones, but that's not true. They expand faster than the rest of the universe. They're dynamic, breathing, evolving regions. Their boundaries push outward. Their interiors stretch. And as they do, they shape the filaments that surround them, just as those filaments shape the voids in return. It's not just one-way influence, it's reciprocity. The voids and filaments create each other. The universe, then, is not like a painting. It's like a symphony. Notes of density and silence, highs and lows, playing against each other in cosmic rhythm. And the KBC void, is one of its deepest tones. A low, resonant note that hums across hundreds of millions of light years, vibrating softly beneath everything we can see. If you could fly through the universe at the speed of light, you would see it unfolding before you. Bright filaments glowing faintly, their tendrils reaching across the dark. Clusters of galaxies like jewels at their intersections, and then the sudden, breathtaking openness of a void, a space so vast and so silent it would make you feel smaller than thought itself. Inside those voids, time runs just a little faster. Space expands just a little more freely. Gravity loosens its grip. It's as if the universe, in those places, exhales. And in that exhalation, the great architecture of everything finds balance. That's the paradox of the cosmos. It is built on absence. Without the voids, the filaments could not stand. Without the silence, there would be no song. The voids give shape to matter. They define the very geometry of existence. Well, and this realization didn't come easily. For decades, cosmologists treated the voids as mathematical leftovers, empty zones of no importance. They focused on the galaxies, the luminous parts, the measurable things. But as the maps grew more detailed, as the computers grew more powerful, a new truth began to emerge. The voids were not noise. They were the structure. It's not just the galaxies that form a network. The voids do too. They connect across billions of light years, touching edges, merging, collapsing, reshaping. The cosmic web is, in a sense, a living system of opposites. Filaments and voids exist in constant dialogue, a push and pull that defines the rhythm of the universe. And that, makes the KBC void not an anomaly, but a key. A clue to understanding how everything fits together. Because when we study the largest void we can find, we're not studying emptiness. we're studying the scaffolding of the cosmos. The great irony is that our own galaxy, the Milky Way, sits not on one of the grand filaments, but in the quiet borderlands between structures. We are, cosmically speaking, suburban, not in the bustling city centers of galaxy clusters, but in the soft, sparse outskirts, close enough to see the brightness, far enough to feel the silence. And perhaps, that's not an accident. Maybe life, fragile as it is, needs this kind of quiet neighborhood to survive. The dense regions are too violent. Galaxies collide. Black holes devour. Radiation burns. But here, near the edges of the void, space is calm. Time stretches. Stars have time to live. Planets have time to cool. And minds have time to wonder. So the cosmic web isn't just a map of matter. It's a map of possibility. It tells us where light gathers, where life might breathe, and where silence reigns. It's not uniform, not even, not simple, but it's precisely this unevenness that gives the universe its depth. And, well, the more we understand the web, the more we see that its beauty lies in balance. Too much matter, and gravity wins. Everything collapses into darkness. Too little, and nothing ever forms. No stars, no galaxies, no questions. But here, between extremes, the universe finds its rhythm. The filaments and voids hold each other in equilibrium, a delicate geometry that allows both motion and meaning. That's why the KBC void is so important. It reminds us that emptiness isn't failure, it's function. It's not the absence of creation, it's the framework for it. The void is the stage upon which everything else performs. And yet, this stage is vast beyond comprehension. Every time scientists map a new region of the universe, they discover the same thing. The pattern repeats. Small voids inside larger voids, filaments within filaments, a fractal of existence. The structure scales up endlessly, suggesting that the universe is self-similar, echoing its own design across unimaginable distances. It's not just out there, it's in here. The same pattern appears in nature, in clouds, in rivers, in the branching of trees, even in the connections of our own brains. It's as though the universe builds everything, from atoms to galaxies, with the same quiet logic. And, when you start to see it that way, the KBC void feels less like an anomaly and more like a mirror. It reflects the deeper truth that creation and emptiness are not opposites, but partners. The universe doesn't grow by filling space, it grows by shaping it. We grow older. Clocks tick. Galaxies drift farther apart. But the web remains. It stretches and flexes, but it doesn't break. It carries the memory of its birth in every strand, every hollow, every quiet region where light rarely goes. And maybe, well, that's where we'll have to go next, to understand not just the geometry of this cosmic foam, but its behavior, its dynamics, the strange way it bends reality itself. Because if the voids expand differently, if they shape the speed of light and the flow of time, then they're not just scenery. They're part of the script. The void is not passive. It's not dead. It's a force, subtle and patient, guiding the evolution of the universe itself. And, maybe that's where the next question lies. Not in the structure, but in the effect. How does this vast emptiness change what we see? How does it shape the light that travels through it, the time that flows within it, the very expansion of the cosmos itself? Well, maybe that's where the next chapter begins. Light doesn't travel the same everywhere. It seems, like such a simple thing, doesn't it? You point a telescope, you measure the light, you chart its path, and you assume that the space between you and the galaxy is neutral, a clean void, a silent bridge. But the truth is, well, the void itself bends that bridge. The KBC void doesn't just sit there as a hollow bubble in the fabric of space. It stretches that fabric. It warps the way light and time move through it. That's the quiet power of emptiness. When matter thins out, when gravity weakens, the balance of the universe shifts. And in those regions where the pull of galaxies fades, something else steps forward: dark energy. That strange, unseen pressure that pushes everything apart begins to dominate. It's not that the laws change, it's that the players do. Gravity retreats, dark energy advances, and inside the voids, expansion takes the lead. So, what does that mean for us, living right here, in the middle of one of the largest voids ever found? It means that everything we see beyond it, every galaxy, every quasar, every flicker of distant light, is subtly distorted by this difference. The photons that reach our telescopes have not traveled through a uniform universe. They've moved through gradients, regions of faster expansion, slower time, weaker gravity. The light curves, not visibly, but in ways that shift its color, its distance, its meaning. Well, and this is where it becomes tricky. When we measure how fast galaxies recede from us, we assume that their speed reflects the universal expansion rate. But if we are inside a region expanding faster than average, our measurements become biased. It's not that the galaxies themselves are running faster. It's that our local space, this vast hollow, is stretching more rapidly beneath them. That illusion makes it seem as though the entire universe is accelerating. In other words, what if some of what we call dark energy isn't out there in the cosmos, but right here, around us, in the geometry of our own cosmic neighborhood? It's not an easy idea to accept. We've built so much of modern cosmology on the assumption that space behaves the same everywhere. But the KBC void, whispers otherwise. Its sheer size means that it has its own internal physics, its own curvature. The gravitational potential within it is different, lighter, thinner. And because of that, both light and time flow differently here than in the denser walls beyond. And, well, that difference ripples outward into everything. The cosmic microwave background, that ancient afterglow of creation, looks slightly cooler in the direction of the void. Cooler because the photons, as they pass through this underdense region, lose a little energy to the faster expansion. It's called the integrated Sachs-Wolf effect, and though tiny, it's measurable. It's the universe's quiet confession that even emptiness has weight, even nothingness has shape. So when we say the void bends reality, we're not speaking in metaphor. The equations of general relativity tell us that mass curves space, yes, but the absence of mass curves it too, just in the opposite direction. Where matter draws space inward, voids push it outward. It's a mirror symmetry, an expansion where there was contraction, a soft acceleration where there once was gravity's grip. And if you think about it, that's a strange kind of beauty. It means that emptiness isn't just passive, it's active, creative in its own quiet way. The voids expand the universe just as the filaments hold it together. One contracts, the other releases. One gathers, the other gives away. It's not destruction, it's rhythm. The deeper consequence, though, is harder to face. If the KBC void expands faster than the universe around it, then our clocks, our distances, even our sense of cosmic history may all be subtly misaligned. The light from distant supernovae which we use as standard candles to measure cosmic acceleration, may not be telling us the whole truth. They appear dimmer not only because the universe is expanding, but because the space between us and them is expanding unevenly. And, that unevenness matters. Because when scientists calculate the so-called Hubble constant, the measure of how fast the universe grows, they're really measuring how fast light stretches across the voids and filaments in between. If one of those voids happens to be enormous, and we're sitting right in the middle of it, then the whole picture changes. That's why some cosmologists now suggest that the KBC void could explain one of the biggest mysteries in physics today, the so-called Hubble tension. Two methods of measurement, two answers. The early universe, as seen in the ancient microwave background, says one number. The nearby universe, measured through supernovae and galaxies, says another, faster, higher. A difference big enough to make scientists wonder if something fundamental is missing. But maybe, it's not missing at all. Maybe it's right under our feet. Or, well, all around us. The KBC void expands more rapidly than average, so the galaxies inside appear to move away faster. We measure that speed. We call it universal. And we panic when it doesn't match what the early cosmos predicts. But it's not the cosmos that's inconsistent. It's our perspective. That realization, quiet and humbling, makes you think differently about the nature of observation itself. We like to imagine ourselves as neutral observers, measuring an objective universe from nowhere. But, there is no nowhere. We are somewhere. And that somewhere bends what we see. It's not just a scientific correction, it's a philosophical one. The void reminds us that observation is always entangled with position, that even in the largest scales, context is everything. It's not that reality is distorted, it's that our view of it is. And so, well, when you look up at the night sky, you're not just seeing stars scattered across an empty black canvas. You're looking through a lens, a subtle curve in space-time shaped by the hollowness around you. Every photon carries the fingerprint of that curvature, slightly redshifted, slightly cooled, slightly aged by the long journey through the void's expanding breath. It's humbling to think that even light, the most constant thing we know, cannot escape the influence of emptiness. The void changes its color, its timing, its path. It's as though space itself whispers to light, bending its message before it reaches us. And yet, well, that bending is precisely what makes the universe visible at all. Without the curvature, without the gravitational gradients and expanding gaps, the light would travel too simply, too straight. There would be no depth, no variation, no story. The void, in its quiet distortion, gives the cosmos its perspective. We sometimes speak of light as truth, as if photons were pure, incorruptible messengers from the past, but they too are travelers shaped by the road they cross. The KBC void teaches us that even truth bends slightly on its way to us, and that's not a failure of truth. It's the texture of it. So, what happens when the void expands? Well, it grows. Slowly, invisibly, over cosmic time. The galaxies near its edge drift farther apart. The boundaries blur. Smaller voids merge into larger ones, forming a hierarchy of hollowness that stretches across the universe like an inverted skeleton. And as that happens, the walls between the voids, the filaments and clusters, become thinner, more strained. Gravity tries to hold them together, but dark energy keeps tugging. It's a cosmic tug-of-war, one that dark energy seems destined to win. Inside the KBC void, this balance is already tipped. The density here is too low for gravity to slow expansion. So space, left to its own devices, accelerates. Every second, every century, the distances grow imperceptibly larger. The stars stay bright in our sky, but their positions drift. Their light stretches. The universe breathes, and we, quietly, unknowingly, breathe with it. And, maybe that's the most haunting part. Because if we're inside this great underdensity, then the future we measure is not quite the future that others elsewhere would see. Time flows differently here. Not dramatically, but subtly. Just enough that our cosmic clock ticks a little faster. The emptiness we live in isn't just outside us. It shapes the rhythm of our existence. Well, when you think about it that way, the KBC void stops feeling like a hole and starts feeling like a field, a vast, invisible current that carries everything along. It bends light. It alters time. It shifts our sense of motion. It's not absence, it's influence. And if that's true, then maybe what we call the accelerating universe is, in part, a reflection of our position inside this deep, expanding cavity. Maybe the cosmos isn't universally speeding up. Maybe it's the hollowness around us that exaggerates the acceleration we think we see. That doesn't mean the discovery of dark energy was wrong. It just means the picture is more complicated. It's not either or, it's both and. Dark energy exists, but its effects are modulated by structure, by the intricate geometry of voids and filaments. The universe doesn't expand evenly because it isn't even. And, well, that unevenness is not chaos. It's the order of the real. We grow older, clocks tick, galaxies drift, and the void slowly stretches its boundaries further into the dark. And somewhere within that quiet expansion lies the next great question. If the void can bend light and time so subtly, what else might it be bending? Because, if even emptiness can shape perception, then perhaps the most mysterious force in the universe isn't dark energy or gravity. It's the simple, silent power of perspective. And maybe, well, that's where we turn next. So, when scientists speak of the Hubble crisis, they don't mean it lightly. It's not just a matter of numbers. It's a question of reality itself. Because, well, the difference between those two measurements of the universe's expansion isn't small. It's persistent, precise, and growing more undeniable with every observation. One says the universe expands at 67 kilometers per second per megaparsec. The other insists it's 73. The numbers, at first, seemed like cousins, close enough to be reconciled. But the more accurate the instruments became, the more the gap refused to close. And that's where the void enters the story again, not as an absence, but as an answer. What if, both numbers are right? What if both methods are correct, but from different vantage points? Because when you live inside a vast underdensity like the KBC void, your view of expansion becomes biased by your own cosmic neighborhood. It's not that the laws of physics are different, it's that the frame of reference is. Imagine standing in the middle of a wide plain that's stretching under your feet. The hills in the distance, dense with rock and trees, resist the stretching. They move more slowly, but the ground right around you, light and loose, expands faster. You'd swear the whole landscape is speeding up, but it's only your corner of it that's racing ahead. That's, exactly the illusion the KBC void could be creating for us. So when we measure nearby galaxies, their motion appears accelerated, not because the universe is expanding faster everywhere, but because our region of space is expanding faster here. It's not just perspective, it's position. We're sitting in the center of a bubble that's breathing quicker than the rest. Well, That might sound like a subtle distinction, but in cosmology, subtlety changes everything. Because this difference, this 9% mismatch between local and cosmic measurements, has been shaking the foundations of the Standard Model. Entire conferences have been dedicated to it. Physicists have proposed new particles, new forces, even cracks in Einstein's theory, all to explain the Hubble tension. But maybe, the explanation isn't exotic. Maybe it's geographic. That's the beauty and the humility of the KBC hypothesis. It doesn't ask us to abandon our understanding of gravity or invent mysterious new energies. It simply asks us to acknowledge where we are, to accept that our cosmic home might not be average, that it might distort what we see. It's not rewriting physics, it's recentering perspective. And yet, the resistance to this idea runs deep. For decades, cosmologists have held fast to the principle of homogeneity, the belief that, on large enough scales, the universe must look the same everywhere. The KBC void defies that serenity. It says, no, not everywhere is equal. It says the universe, like everything else that evolves, carries scars of its own birth. The problem, though, is one of scale. The void is so immense, nearly 2 billion light-years across, that it stretches the limits of what our simulations can produce. Computer models of cosmic evolution rarely generate voids this large, this clean, this empty. That's part of what makes it controversial. If it's real, it's rare. And if it's rare, it challenges the very randomness of cosmic structure. Still, well, the data keep whispering the same story. Surveys of supernovae, galaxy velocities, and light from quasars all hint at a local underdensity. It's not a coincidence. It's a pattern that aligns precisely with what the KBC team predicted. And, when you see a pattern like that, you have to start wondering whether coincidence is too weak a word. So what does this mean for the so-called crisis? It means the tension between those two Hubble numbers might dissolve once we factor in our void. When scientists inside the KBC region measure nearby expansion, their results reflect the faster local rate. When others, observing the cosmic microwave background, the relic light from the early universe, measure expansion on a grander scale, they're seeing the slower, global rate. Both are true. Both are honest. They're just speaking different dialects of the same cosmic language. And, well, that has profound implications. Because if this is right, then the universe isn't broken. It's just uneven. The tension is not a flaw in physics. It's a feature of geography. The cosmos, in its vast complexity, refuses to be perfectly smooth. It's not the first time perspective has fooled us. We once thought the Earth was the center of everything, simply because everything appeared to revolve around us. The KBC void might be our modern Copernican correction, the moment we realize that even in cosmology, vantage point matters. We're not at the center of the universe, but we might be at the center of a distortion. And that's humbling, because it reminds us how fragile measurement is, how every ruler we hold is bent, just a little, by the space it rests in, the speed of expansion, the age of the cosmos, even the fate of all things. Each is filtered through the lens of where we stand. But, well, this realization also brings something beautiful. It tells us that the universe still has room for discovery, that even after a century of mapping the heavens, there are subtleties we haven't yet seen. The KBC void isn't a dead end. It's an invitation to refine how we observe, how we model, how we imagine. That said, the debate is far from settled. Many researchers argue that the void alone cannot account for the entire Hubble discrepancy. The numbers line up intriguingly, yes, but the evidence remains circumstantial. Others point out that even if we are inside such a massive underdensity, the effect might not be large enough to explain the full difference. But, that's the beauty of science. It thrives in that uncertainty. The tension itself drives curiosity forward. And, perhaps it's worth remembering that cosmic history is a series of such tensions. Every leap in understanding was born from an inconsistency. Newton's gravity couldn't explain Mercury's orbit. Einstein's relativity stepped in. The static universe Einstein imagined couldn't fit Hubble's expanding one. Dark energy emerged to balance the scales. The Hubble tension might be the next such turning point, the signpost pointing us toward a deeper layer of truth. So maybe the KBC void is not the full solution, but part of one. Maybe it's one piece of a greater puzzle, a clue toward how matter, energy, and geometry conspire to shape our observations. The void may not end the crisis, but it reframes it. It shows us that cosmology isn't just about equations, it's about context. And, if you think about it, that realization mirrors something deeply human. We, too, see the world through local distortions, our upbringing, our position, our limited view of time. The universe, it seems, behaves the same way. It perceives itself unevenly, each region with its own rhythm, its own curvature of truth. Well, that's both unsettling and comforting. It means that imperfection is not an error. It's the fabric of existence. The void doesn't destroy meaning. It defines it. Without it, there would be no contrast, no motion, no measure of expansion at all. And yet, the implications reach farther still. If our local environment can bias the measurement of something as fundamental as the Hubble constant, what else might it distort? Could the void also influence how we perceive cosmic acceleration itself? Could it alter our understanding of dark energy, of time, of fate? These are not rhetorical questions. They're the edge of what we know. The void invites us to re-examine every assumption about uniformity, every simplification we've made for convenience. It reminds us that the universe, in all its elegance, does not owe us simplicity. We grow older, clocks tick, galaxies drift, and the data keep arriving. Each photon another fragment of the great conversation between light and emptiness. And the more we listen, the more the message becomes clear. The crisis is not a breakdown, it's an opening. Perhaps the KBC void will not end the debate, but it will deepen it. It will make cosmologists question not just how fast the universe expands, but where and why it does so unevenly. It will make us confront the possibility that there is no single rate of expansion, only a patchwork of rhythms stitched together across cosmic time. And that, brings us to something even stranger. If the void explains part of the Hubble tension, then it suggests a new kind of relativity. Not the relativity of motion or gravity, but the relativity of expansion. Each region of space may live at its own tempo, each pocket of the cosmos unfolding at a slightly different pace. The universe, then, isn't a single melody. It's a choir of expanding notes, each resonating through its local void or filament. That idea changes everything, because it means cosmology isn't about finding one number, it's about mapping the harmony between many. The Hubble constant might not be constant at all, but contextual, a function of where you are, not what you measure. Well, that's a dizzying thought, but it's also liberating. It frees us from the illusion of uniformity and brings us closer to the living texture of the cosmos. It reminds us that truth, even cosmic truth, is layered. It's not flat. It's curved. And maybe, that's where the real story begins. Not with crisis, but with connection. Not with contradiction, but with perspective. The void doesn't break our understanding. It expands it. It tells us that the universe, in its vast complexity, still has corners left unlit, mysteries left unsolved, rhythms left unheard. And, well, perhaps that's where we should turn next. Not just to the numbers, but to the principle that the void quietly undermines, the very assumption of cosmic uniformity. Because if the KBC void is real, and if it truly bends our view of the universe, then we may not just be measuring differently. We may be living in a universe where difference itself is fundamental. And that, is the next question waiting in the dark. It's strange, how an idea can make you both small and central at once. The moment we realize we might be sitting inside this enormous void, the ground beneath our understanding of the universe starts to shift. For so long, well, we've trusted the cosmological principle, the idea that, on large enough scales, the universe is uniform, isotropic, indifferent. No favored positions, no privileged observers. Everywhere should look roughly the same. That principle has been the quiet foundation of cosmology for a century. A promise that we are ordinary, unexceptional, a part of a grand, balanced whole. And yet, here we are, perhaps at the center of one of the largest empty regions ever discovered. Not just within it, but eerily near its middle. It's not just an observation, it's a paradox. Because if that's true, then the universe may not be as self-similar as we thought. It's not just that we're small, it's that our smallness might occupy a very special place. So what do we do with that? What does it mean to live in the center of absence? For some scientists, it's a coincidence, a statistical quirk. For others, it's deeply unsettling, a sign that maybe our assumption of mediocrity, the Copernican ideal, doesn't fully apply. Because if the cosmos is indeed homogeneous, then what are the odds that we'd end up right here, in this vast hollow where galaxies are sparse, expansion runs faster, and light itself stretches a little thinner? The odds, are low. Very low. The models say such voids can form, yes, but they shouldn't be this big, and certainly not this centered around us. The probability of that alignment, of us being here, is less than 1 in 1,000. And still, well, here we are. That realization unsettles something ancient in us, because we've spent centuries crawling away from the notion of centrality. From the Earth-centered universe of Ptolemy, to the sun-centered revolution of Copernicus, to the endless cosmic horizon of Hubble, every discovery has pushed us farther from the middle. Each step has whispered, "You are not special. You are not central. You are not chosen." But the void, whispers differently. It says, maybe you are central, at least in this hollow. Maybe you are, by chance or by consequence, standing in the middle of a cosmic breath. And that, well, that sounds uncomfortably close to old patterns of thought, the kind that science once fought to escape. It's not just a scientific question, it's a philosophical one. If the universe can produce regions this uneven, then no special place is no longer guaranteed. It's not that we're at the center of everything, but perhaps we're at the center of something. And even that small distinction feels enormous. We tend to resist it. Scientists use words like statistical fluke, selection effect, anthropic bias. They remind us that coincidences happen because, well, someone has to observe them. If consciousness arises somewhere, it will always look around and think its vantage point is meaningful. It's not that we're central, It's that we exist, and existence requires a stable, quiet neighborhood. So, maybe, our presence here is not privilege, but necessity. The dense regions of the universe are violent. Radiation, collisions, turbulence. Life, fragile as it is, would struggle there. But here, inside this cosmic bubble, time flows softly. Space expands gently. It's calm enough for stars to age, for planets to settle, for thought to emerge. Maybe that's the only reason we're here at all. Well, it's not that the universe chose us. It's that we could only have arisen in this kind of place. Still, the coincidence remains haunting. We grow older, clocks tick, galaxies drift apart, and all the while, we find ourselves poised in the quiet middle of the largest emptiness we've ever found. And, maybe the void isn't violating the cosmological principle after all. Maybe it's only testing it. The principle says that the universe appears the same from any sufficiently large vantage point. But how large is large enough? 1 billion light years? 2 billion? Maybe the KBC void reminds us that the scale of uniformity is not infinite, that even the universe has texture, that homogeneity is only approximate. That's the real challenge. The universe doesn't promise perfection. It promises patterns. And within those patterns, exceptions must live. The void may be one of them, a statistical outlier that forces us to rewrite how we think about cosmic averages. Still, there's something oddly poetic in it. To imagine that our cosmic address lies not in a crowded cluster, but in the middle of silence. That we gaze out from a seat carved by absence, surrounded by the faint light of distant galaxies shimmering on the edges of a hollow. It's not grandeur, it's grace. And yet, well, some take this further. They ask, what if it's not chance at all? What if the structure of the void, its symmetry, its central alignment with our local group, isn't accidental? That's a dangerous question, because it brushes against forbidden territory, against the very idea of design, or purpose in cosmic arrangement. Scientists, understandably, recoil from that implication, but the question persists. It's not that the void proves intention. It doesn't. But it reminds us that even in randomness, patterns can look personal. We crave meaning in geometry, purpose in placement. When the data puts us in the middle of something vast and rare, our minds reach instinctively for narrative. And, that instinct isn't wrong. It's human. But the void's lesson may be subtler than purpose. It may be about perception itself. The universe isn't built to flatter us, but it is built to surprise us. Each time we declare our insignificance, it hands us a paradox, a reason to question how we define ordinary. We're ordinary in substance, yes, atoms, carbon, dust. But the arrangement, the circumstances, the balance that allows those atoms to think and wonder, those are anything but ordinary. It's not that we're special in the cosmic sense, it's that we exist at all, here, in this fragile equilibrium between gravity and expansion, matter and emptiness. That equilibrium, depends on the void more than we think. Without these hollows, the cosmic web wouldn't breathe. The dense clusters would collapse faster. The filaments would crowd tighter. The night sky would look different. Denser, harsher, maybe lifeless. So, well, perhaps the void is not our exception, but our condition. Still, the cosmological principle trembles under its weight. Because even if the void fits within the broader fabric of homogeneity, our place within it gives us a privileged perspective. We measure expansion, redshift, time, all from a location that isn't neutral. And that realization makes cosmology less about the universe out there and more about the interplay between there and here. It's not just a void, it's a mirror. It shows us that our desire for symmetry might be a projection, not a property of reality. That the universe isn't perfectly even because perfection was never the goal. The goal, if it has one, is variation. And, that makes sense. Variation drives creation. Difference fuels motion. Without imbalance, there is no growth. Without voids, there are no filaments. Without silence, no sound. The universe needs its imperfections. Their asymmetry is its engine. Well, so maybe the violation of the cosmological principle isn't a flaw at all. Maybe it's a revelation. It tells us that the universe isn't bound by our ideals of fairness. It's not just symmetrical. It's self-organizing, dynamic, alive in pattern. That doesn't make us special. It just makes us situated. Situated in a region that is quieter than most, older in its flow, slower in its density. But from that quietness, consciousness has arisen, and from that consciousness, curiosity. So the void becomes both our home and our teacher. And yet, the paradox remains unresolved. Because if we're central in this vast emptiness, even by accident, then the cosmological principle is wounded, not dead, but bruised. We can no longer claim the universe looks the same from everywhere, only that it rhymes. We grow older, clocks tick, galaxies thins out in our corner of the web, and the boundaries of the void stretch farther, faster. The more we learn, the more we realize that uniformity was a simplification, a beautiful one, but still a simplification. The real universe breathes in gradients. And, that changes how we think of center. Because maybe the center isn't about position, it's about perception. We are central not because the universe places us there, but because our awareness radiates outward from wherever we stand. Every observer, in every corner of every void or cluster, carries their own center within them. The cosmological principle, rewritten, becomes not a statement about space, but about consciousness. Well, maybe that's too poetic for physics, but physics keeps colliding with poetry the deeper it goes. The void forces us to reconcile the measurable and the meaningful, the scientific and the existential. It's not enough to ask how space expands. We must ask what it means to exist within that expansion. And so, as we stand in this hollow of galaxies, surrounded by the dim shimmer of distant clusters, we begin to sense that the real story isn't about the violation of any principle. It's about the emergence of a new one. A principle that accepts variation, that embraces locality, that treats difference not as distortion, but as depth. Maybe that's the next step in understanding, not to deny that we live in a special place, but to redefine what special means. It's not chosen. It's not divine. It's simply improbable. And in the language of the universe, improbability is the birthplace of wonder. And, well, perhaps that's where the next question arises. Not from our place in the void, but from how the void came to be at all. Because if this hollow truly exists, if it truly shapes our sky and bends our perception, then something in the earliest moments of the cosmos must have seeded it. Something small, something quantum, something impossibly ancient. And maybe, that's where the next story begins, far before us, in the trembling fabric of the newborn universe. So, if the void truly surrounds us, if it breathes and bends reality the way we think, then we have to ask, where did it come from? Because, well, nothing that large just appears. It must have roots, deep roots, reaching all the way back to the first seconds of the universe. The KBC void, enormous as it is, may not be a late accident. It might be a fossil, a remnant from the earliest quantum whispers of existence. After the Big Bang, the universe wasn't the uniform sea of light we sometimes imagine. It was uneven, a frothing, jittering chaos of fluctuations. Tiny, variations in density, so small that they existed only as quantum ripples in the infant field of energy. Those ripples, those microscopic wrinkles in space-time, were, in a way, the first fingerprints of structure. Where there was a little more energy, gravity began to tug, gathering matter. Where there was a little less, gravity let go, leaving behind small voids. And those differences, were magnified as the universe expanded. Inflation, an unimaginably fast swelling of space, took what was quantum and stretched it to cosmic. A bump the size of an atom became the seed of a galaxy. A dip the size of a proton became the seed of a void. It's not just that the universe grew, it amplified its own imperfections. That's the irony, isn't it? The flaws in the beginning became the patterns we now see. The universe wasn't built out of symmetry. It was born from imbalance. And, maybe the KBC void is one of those imbalances carried to its extreme. A single quantum fluctuation, magnified through 14 billion years of gravity and expansion, becoming this vast, soft cavity that now holds us inside. When scientists simulate the early universe, they can trace these origins in mathematical echoes. The primordial power spectrum, a kind of ancient blueprint of density waves. The waves are, like the harmonics of creation itself. Each peak and valley corresponds to where matter gathered or withdrew. And, well, if one of those valleys was just a little deeper, just a little broader, it could have become what we now call the KBC void. We don't often think about how fragile those beginnings were. A slightly different fluctuation, a slightly different quantum hiccup, and the story of everything, of galaxies, of stars, of us, might have unfolded differently. That one extra nudge in the early field could have made a region like ours even emptier, or erased it entirely. Whether it exists at all might have come down to randomness, to the way uncertainty itself froze into matter. It's not just randomness, though. It's rhythm. The universe oscillated. It hummed. Those quantum vibrations weren't isolated. They interacted, interfered, combined. They made chords of density and void, like sound waves shaping a cosmic symphony. And the melody, continues even now. Every galaxy, every dark patch between them, still carries that original note. So when we speak of the KBC void, we're really speaking of an ancient resonance, a pattern born before time, stretched across eternity. The light that passes through it isn't just moving through emptiness, it's moving through a memory. And, well, that's the strange beauty of it, because it means that the vast hollowness around us isn't a sign of cosmic decay, it's a signature of birth. It's not what's left after creation, it's part of the creation itself. Well, if that's true, then the void isn't something that happened to the universe. It is the universe, just in another mode. Where galaxies are the punctuation, voids are the silence between words, the necessary stillness that gives meaning to the rest. But, there's still the question of how something this large, this perfectly centered around our region, could survive the rough dynamics of cosmic evolution. The universe should have ironed out its extremes by now. Gravity pulls, energy disperses, balance returns. And yet, the KBC void remains, like a ghost of those first fluctuations that refuse to fade. Some physicists suggest that this persistence hints at something deeper, something in the early inflationary phase that favored certain scales, certain wavelengths of fluctuation. Maybe the void corresponds to one of those special frequencies, a resonance locked in when the universe was still quantum. It's not just an accident, it's a harmonic echo frozen in space-time. And that idea is breathtaking. It means that we are living, literally, inside an echo, a vibration stretched into emptiness, a fossilized wave that once rippled through the newborn cosmos. The void becomes not an absence, but a record. When you think about it that way, it feels less like we're lost in nothingness and more like we're suspended in the afterglow of the beginning. The silence isn't emptiness, it's memory. So maybe that's the real answer to where the KBC void came from. Not from collapse or coincidence, but from the faintest quantum heartbeat of creation. That the same randomness that built the stars also built the hollows between them. The same field that gave rise to galaxies also carved the space in which they hang. It's not two processes, it's one, mirrored. We grow older, clocks tick, and the universe keeps stretching. But the pattern set in motion long ago still guides it. The densest regions keep clustering, the emptiest keep expanding. It's a dance of contrast, a dialogue between gravity and vacuum, between matter and meaning. And, perhaps that's the real role of the voids, to give the universe dimension. Without them, everything would collapse into sameness. It's not the galaxies alone that define the cosmos, it's the space between them. Well, that sounds almost poetic, but physics keeps proving it true. When cosmologists simulate the universe, they find that voids are essential to maintaining its balance. They absorb expansion, distribute tension, keep the cosmic web breathing. Without them, the structure would fragment. With them, it flows. That balance feels intentional, though it isn't. It's what happens when the laws of physics play themselves out across eternity. The void and the filament, the dense and the thin. They are each other's opposites, and each other's necessity. And, maybe that's why the KBC void feels so strange to us. Because in its scale, it mirrors something within us. We too are made of contrasts, of presence and absence, of awareness and forgetting, of meaning and the quiet beyond it. The void outside reflects the void within, not in despair, but in structure. It's not out there, it's in here. Maybe that's why we keep studying it. Not just to understand space, but to understand the conditions that make space meaningful. To see how something so empty can hold so much significance. To realize that even absence can create, can shape, can endure. And when we follow that thread, when we trace those faint quantum ripples back to the first second of existence, we begin to see that everything, every star, every planet, every breath, is descended from fluctuation, from noise, from uncertainty given form. The universe is not a perfect plan. It's a self-organizing accident that learned to remember. And the KBC void, may be its greatest reminder. The echo that whispers, even nothing has history. We grow older, clocks tick, and light keeps traveling through that silence. Every photon we catch carries not just information about galaxies, but about the fluctuations that shaped them. Every measurement is a message from that primordial moment. So, when we look up at the sky, we are really looking back into the first trembling of being. The KBC void is not a void in the human sense. It's the shadow of the beginning stretched thin. And maybe understanding its origin won't just explain how the universe formed. It might help us understand how it still changes. Because if those quantum ripples still echo through space, if they still sculpt the large-scale structure today, then the void isn't just a relic. It's an active process. It's not just history. It's happening. And, well, that thought leads us naturally to another question. If the void was born from the quantum heart of the universe, what does it tell us about the most mysterious force that drives it now? The one that still pushes it apart? Because, somewhere inside this emptiness lies the key to dark energy itself. So, when we talk about dark energy, we're really talking about the universe's quiet heartbeat, the invisible pressure that keeps everything apart. It's not just a force, it's the rhythm of expansion itself. For decades, scientists have known that the cosmos isn't merely expanding, it's accelerating. The galaxies aren't just moving away, they're speeding up, as though pushed by some unseen hand. And, the strangest part is that we still don't know what that hand is made of. It's not gravity. It's not matter. It's not even light. Whatever dark energy is, it makes up almost 70% of everything. And yet, it remains hidden, untouchable, untested. But maybe, well, the KBC void can help us touch it indirectly. Because if there's any place in the universe where dark energy might reveal its nature, it's here, in the emptiest places, in the cosmic hollows where gravity loses its grip. It's not just in the dense clusters where matter dominates, but out here, where there's almost nothing left to resist expansion, that dark energy writes its clearest signature. The void becomes, a laboratory of nothingness, an experiment set up by the universe itself. That idea is both eerie and elegant. It means that by studying the very absence of matter, we might uncover the essence of what drives existence. The less there is, the more clearly dark energy speaks. When we observe galaxies at the edge of the KBC void, they drift faster, as though the space around them is stretching at a slightly different rate. Well, that's not just coincidence. That's physics in slow motion, revealing a deeper truth. In voids, the balance tilts. Gravity fades. The fabric of space-time becomes looser. And in that looseness, dark energy, the smooth, persistent energy of the vacuum, takes over. We used to think dark energy was constant, an unchanging property of space itself, the so-called cosmological constant. But, the behavior of voids like ours suggests something subtler. Maybe dark energy isn't fixed. Maybe it fluctuates, breathes, evolves. Maybe it's stronger in the emptiest regions, weaker in the crowded ones. It's not that space expands everywhere equally. It's that expansion depends on what space contains. And that, would mean the universe is not uniform even in its acceleration. It's not just stretching, it's breathing unevenly, pulsing differently in its hollows than in its hubs. Well, imagine that for a moment. A living universe, not mechanical but organic, swelling faster in its silent lungs, slower in its dense bones. The KBC void, in that sense, isn't just a location, it's a pulse point, a place where the cosmic heartbeat is exposed. And, that could be why studying our local void has become so important. Because if we can measure exactly how fast it expands compared to denser regions, we can begin to map dark energy's character, not just its strength, but its nature. Is it truly constant, or is it dynamic, shifting with time, with emptiness, with history? Some scientists, suggest that voids are like amplifiers. Because they contain so little matter, even the faintest influence of dark energy becomes visible there. Light passing through them bends differently. Galaxies within them move with a gentler but faster drift. every observation is like listening for echoes in a quiet chamber. The fewer distractions, the clearer the sound. That's what the KBC void gives us, a silence large enough to hear the universe thinking. And yet, well, measuring such subtle effects is brutally difficult. The signals are faint, the data complex. The universe doesn't give up its secrets easily. Still, with better telescopes, with new sky surveys, with instruments like Euclid and the Vera Rubin Observatory, scientists are finally beginning to listen in higher resolution. We grow older, clocks tick, detectors cool in the dark, waiting for photons that have crossed billions of years to tell us how space has stretched. And each faint flicker adds to the picture, an invisible tide mapped one wave at a time. It's not just curiosity, it's necessity. Because understanding dark energy isn't optional. It defines the future. If it remains constant, the universe will continue expanding forever, growing colder, lonelier, dimmer, a slow dissolve into eternal silence. But if it changes, if it evolves, then everything could end differently. It might fade away, letting gravity pull things back together. Or it might grow stronger, tearing galaxies, atoms, even space-time apart. The fate of everything, hinges on what this invisible force truly is. And the void, ironically, might hold the clue. The emptiest place could explain the ultimate destiny of fullness. Well, that's the strange poetry of physics, isn't it? That you must study absence to understand existence. That the most silent parts of the cosmos tell you the loudest truths. The KBC void, with its slower gravity and faster expansion, becomes a stage where dark energy performs unmasked. And, maybe this is why our position inside it isn't coincidence, but opportunity. We're not cursed by emptiness. We're privileged by perspective. Because from inside a void, the effects of dark energy are magnified. From here, we can see the universe accelerating more clearly than if we were buried in a dense cluster. It's not that we're special, it's that we're placed at the perfect distance from noise to hear the faint hum of the vacuum itself. That, realization is both scientific and spiritual. It means that in this vast hollowness, where galaxies are sparse and silence reigns, we've found not meaninglessness, but measurement. Not isolation, but insight. And yet, there's another layer to all this. If voids accelerate faster, if dark energy behaves differently inside them, then perhaps the very concept of universal expansion is flawed. Maybe there is no single rate of cosmic growth, only a web of local accelerations stitched together into something that looks smooth from far away. So when we speak of the universe expanding, we're speaking in averages. But the truth, is patchy, uneven, textured. Just like the fabric of human experience, it's not a uniform story. It's a pattern of contrasts. That doesn't make it less beautiful. It makes it more alive. And, well, the implications go beyond physics. Because if dark energy interacts differently with matter, it could mean that the universe's structure itself affects its future. That the very way galaxies and voids arrange themselves feeds back into cosmic acceleration. It's not just expansion happening to matter, it's matter shaping, expansion, the observer and the observed, locked in an endless mutual influence. That blurs the line between cause and effect, between the stage and the actor, between void and vitality. We grow older, clocks tick, galaxies drift, and dark energy continues to hum beneath it all. Maybe it's not a constant. Maybe it's a story still being written, changing as the universe breathes, as time itself unfolds. And if that's true, if the void reveals that dark energy is not fixed, but living, responsive, then our role in studying it becomes something deeper. We're not just recording the end of the universe, we're part of how it learns to expand. Well, that sounds grand, maybe too grand, but it's hard not to feel awe when you realize that the greatest mystery of existence might be whispering right through the emptiness that surrounds us. The KBC void isn't an anomaly, it's an opportunity. It's where the cosmos teaches itself how to grow. And, as the data gathers, as new maps of voids and filaments appear, we begin to suspect that dark energy might not be one simple thing, but many. A field, a fluctuation, a memory of inflation still echoing through time. Whatever it is, it's not passive, it's not distant. It's here, stretching every atom, shaping every second. That realization is where science begins to tremble toward philosophy again. Because if dark energy changes, then so does destiny. And if our local void helps reveal that change, then perhaps, our small place in the cosmos is not meaningless after all. And as we keep measuring, keep listening, keep staring into this great quiet, we can't help but wonder, if dark energy defines the future, then what does its whisper tell us about the models we've trusted so long? Because, the next chapter of this story isn't about what we've found, but about what might be breaking beneath the surface of what we thought we knew. So, the more we learn from the KBC void, the stranger the universe becomes. Every discovery that should clarify things only deepens the fog. The farther we reach, the more uncertain the ground beneath our theories feels. It's like, we've built this elegant model, this lambda cold dark matter framework, and it's worked so beautifully for so long, predicting galaxies, cosmic microwave background, large-scale structure, and, then the void came along, silent and vast, and quietly asked, "Are you sure?" That's the unsettling thing, because LCDM, our standard model of cosmology, has been almost sacred. It assumes that general relativity works everywhere, that dark matter behaves predictably, that dark energy is a constant, and that the initial universe was smooth except for tiny random ripples. Everything we see, clusters, filaments, supernova, fits neatly inside that framework. Until we found something that doesn't. The KBC void isn't just large, it's too large. Its existence shouldn't happen under this model, at least not so perfectly centered around us. We've tried to make it fit. We've run simulations, millions of them, varying density fields, dark matter distributions, initial perturbations. But, no run produces something quite like this. It's as if the universe, in its infancy, drew one improbable breath and never exhaled evenly again. The probability of a void like ours forming by chance is smaller than 1 in 1,000. It's not impossible, no, but it's uncomfortably rare. And, well, when coincidence becomes that rare, science starts to fidget. So maybe, the model itself is trembling. Maybe LCDM isn't wrong, it's just incomplete. Like a song missing its final verse. Some physicists have begun to wonder whether gravity itself might change over enormous scales. It's not that Einstein's equations fail nearby. They work perfectly. For stars, planets, even galaxies. But maybe, well, the universe doesn't obey the same rules across billions of light years. Modified gravity theories like MOND or TVES have tried to test that idea, stretching the equations of relativity to see if, in the thin air of cosmic voids, the force behaves differently. And if it does, If gravity weakens slower than we think, or acts differently through the fabric of emptiness, then maybe these giant voids aren't anomalies at all. Maybe they're part of the natural rhythm of a more complex universe. It's not that our equations are broken, it's that our vision is small. That possibility frightens and excites scientists in equal measure. Because if gravity behaves differently at large scales, it means our entire map of cosmic evolution must be rewritten. The galaxies would have grown under slightly different laws. The web of matter would have woven differently. The Hubble tension might dissolve not from error, but from ignorance. And, then there's dark matter. The invisible skeleton of the universe, the unseen mass that gives galaxies shape and binds the cosmic web. We've treated it as simple, cold, slow-moving, obedient to gravity. But what if it isn't? What if, dark matter interacts with itself in ways we haven't yet seen? Self-interacting dark matter could clump differently, leaving behind vast, smooth voids like scars between the filaments. It's not just about how much dark matter exists, it's about how it behaves. Well, if that's true, then the KBC void might not be a contradiction. It might be a clue, a hint that dark matter, like us, has more to its nature than we assumed. Maybe it cools or decays. Maybe it forms halos that dissolve over cosmic time. The void, then, becomes the ghost of dark matter's evolution, its history written in negative space. We grow older, clocks tick, and every new observation makes the pattern murkier. Each adjustment to the model seems to open two new questions. Some cosmologists suggest that the early universe, during inflation, might not have been perfectly uniform after all. Inflation was supposed to smooth everything out, to stretch space so evenly that every direction looked the same. But what if it didn't? What if, certain regions inflated just slightly faster or slower? That tiny imbalance, amplified across 14 billion years, could produce voids like ours. It's not that inflation failed, it's that it might have been asymmetric. That's both elegant and disturbing. Elegant because it explains the void without breaking physics. Disturbing because it means the seeds of cosmic unevenness were sown in the first instant of time itself. It wasn't random chance, it was the birthmark of creation. And, if inflation wasn't uniform, then the principle of cosmic mediocrity, our belief that no place is special, starts to fracture. Because if the early field had variations that favored certain regions, then our place might be one of those favored spots. The void wouldn't just be coincidence, it would be legacy. That, thought lingers. It suggests the universe might have memory, that the structure we see today carries whispers of what it once was. The KBC void, in that sense, isn't just a gap. It's an ancient echo, the last note of an unfinished song. We keep adjusting the parameters, adding corrections, refining constants, and still, something doesn't quite align. It's as if the universe keeps moving the goalpost every time we think we've reached it. The LCDM model holds, mostly, but it doesn't feel final anymore. The discrepancies are small but persistent, like static on an old radio. And static, always means there's another signal underneath. Maybe that signal is quantum. Maybe it's hidden in the vacuum energy, in the faint trembling of the Higgs field, or some unknown particle that connects dark matter and dark energy. Some physicists even suspect that what we call dark energy might be an emergent property of spacetime itself, a pressure that arises from the entropy of the universe expanding. If that's the case, then voids are not anomalies. They're inevitabilities, places where entropy rules strongest. Well, it's dizzying, isn't it? To think that our cosmic home could both prove and challenge the foundation of physics. That the very place we inhabit might be rewriting the equations we thought eternal. It's not that the universe is mocking us. It's that it's still speaking, still changing its dialect as we learn to listen. We once thought the cosmos was stable, predictable, lawful. Now we see that its laws might themselves evolve. Gravity may bend differently, matter may whisper through unseen forces, and time may stretch unevenly across the emptiness. The void has forced us to face that possibility. And, maybe that's the point. The KBC void isn't an error. It's an invitation to look deeper, to think wider, to accept that even the best models are stepping stones, not monuments. The universe doesn't promise simplicity. It promises truth. And truth, rarely sits still. So as we stand inside this vast hollow, surrounded by the thin light of galaxies billions of years away, we start to realize something quiet but profound. The standard model doesn't fail because it's wrong. It fails because it's too right for a universe that keeps growing stranger. And, well, that strangeness is the doorway to what comes next. Because if the void can shake the pillars of cosmology, then perhaps the next chapter isn't about models or measurements at all. Perhaps it's about meaning, about what it means to exist in a place so empty, and yet so alive with mystery. So, maybe this is where everything finally comes to rest. After all the searching, all the equations, all the light years of wonder and confusion, we find ourselves standing quietly in the middle of the void, our own cosmic reflection staring back at us. It's strange, how the journey outward always circles back inward. The farther we reach into the universe, the deeper we fall into ourselves. We once thought that to understand the cosmos was to conquer it, to map every star, to measure every distance, to name every force. But the truth, well, the truth feels softer than that now. Understanding doesn't conquer, it connects. It reminds us that the void is not our enemy. It's our origin. It's not that we look into nothingness, it's that we were born from it. Every atom, every heartbeat, every thought we've ever had was once part of the same silent sea. And, when you realize that, something quiet happens inside you. You stop fighting the emptiness. You start hearing it. The silence of the KBC void, once terrifying, becomes something else. Something vast, yes, but also gentle. It's not the darkness that erases light. It's the space that lets light exist. Without emptiness, there's no room for anything to begin. Without distance, no perspective. Without the quiet, no music. That's what the void teaches, isn't it? That nothingness isn't the opposite of being, it's the condition for it. We need it. The universe needs it. Life itself needs it. Without space to grow, to breathe, to wonder, meaning has nowhere to unfold. And we are creatures of unfolding. Well, I used to think the cosmos was cold, vast, indifferent, mechanical. But standing here, metaphorically speaking, inside the largest void known, I don't feel cold anymore. I feel awe. The kind of awe that humbles you and lifts you at the same time. Because the void doesn't ignore us. It holds us. It gives us context. We are the momentary spark of awareness flickering within its endless quiet. We are how the universe sees itself, even if only for a second. And, that second is everything. Out of all the infinite possibilities, here we are, in this particular time, in this particular void, on this fragile blue world, wondering why. The question itself is a kind of miracle. The asking gives the void purpose. It's not just emptiness stretching outward, it's curiosity stretching inward. We grow older, clocks tick, galaxies drift farther apart, and one day, even the light between them may fade. But that doesn't erase meaning. It preserves it. Because every thought, every discovery, every whisper of wonder is a trace left in the dark. A ripple that says, something here once cared to understand. The universe may forget us, but for now, it remembers itself through us. And, maybe that's what eternity truly means. Not endless time, but enduring connection. The stars that died to create our atoms are gone, but their story continues in our breath, in our words, in our seeing. The void is not the end of that story. It's the page on which it's written. That, realization changes everything. It means our smallness isn't insignificance, it's intimacy. It means that in all this darkness, we are not lost. We are placed, perfectly, improbably, tenderly placed in the only universe that could have made us. We are not apart from it. We are its continuation. And, well, perhaps that's the meaning we've been searching for all along. Not to escape the void, but to embrace it. To understand that silence can be sacred, that absence can be alive, that even in the hollowness of space, there is something luminous waiting to be seen. Not outside, but within. So maybe the final truth isn't in the equations or the stars, but in the pause between them. The same pause that exists between one breath and the next, between the question and the answer, between nothing and everything. We live in that pause. We are that pause. And as the universe expands, as time stretches further into the unknown, maybe all it ever wanted was this: a moment of awareness, fragile but bright, flickering within the infinite. A single conscious gaze that turns emptiness into meaning. Well, if that's true, then the KBC void isn't just a mystery we've solved. It's a mirror we've looked into, and finally recognized ourselves. And maybe that's enough. Maybe it always was. So, when everything quiets, when the last equations fade and the sky returns to silence, what remains is not confusion, but clarity. The KBC void, vast and empty as it seems, has become something more than a discovery. It has become a mirror. A mirror that, shows us what the universe really is and what we are inside it. It's not a place of absence. It's the structure of being itself. Without the void, there could be no galaxies, no stars, no light, no us. That realization changes how we see everything. It's not that existence defies emptiness, it's that it rises from it. The darkness that fills most of space isn't an accident. It's the reason light can shine at all. We are not living despite the emptiness. We are living because of it. The void is not death. It's the breath between creation and awareness. And, when you think of it that way, the universe stops feeling hostile. It becomes tender, almost fragile. It becomes something that is, at once, infinite and intimate. Because the same laws that govern distant galaxies are written in the atoms of our skin. The same silence that drifts between stars also waits in our thoughts. We look out at billions of light years and see only distance. But maybe distance isn't separation. It's connection stretched thin enough to reveal its own transparency. The KBC void doesn't divide us from the cosmos. It joins us to it, as the pause joins sound, as space joins matter. Well, perhaps that's the quiet truth. The universe is not meaningless. It's just patient. It hides its purpose not in complexity, but in contrast. light and dark, fullness and emptiness, presence and absence. And somewhere between those opposites, somewhere right here, awareness flickers awake. So when we stare into the black, we are not gazing into nothing. We are gazing into the source of everything, into the place where time began and meaning learned to speak. The KBC void is not a warning about our smallness. It's a reminder of our belonging. And in that vast, silent belonging, maybe we finally understand. The universe does not ask to be conquered or explained, only to be witnessed gently for what it is. Not emptiness, but possibility.